Okay, we are going to go into the second chapter of this book by Luber and Lemery, the chapter 2. So we are still in part 1, looking at health risks from climate change. We are focusing here on extreme weather events. The tagline, the role of public health in disaster risk reduction as a means for climate change adaptation, is key because much has been discussed by the IPCC reports and various other research articles, reports, World Bank, and so on about extreme weather events across the world and vulnerability to them, the risks associated with them. We want to put that slightly in a different context here in terms of how public health outcomes are affected by these weather events, and how we can think of sustainable development and disaster risk reduction with public health as one of the components, so that becomes part of the solution altogether. And there is no advantage, or in fact there is great disadvantage to thinking of them as separately. For example, you can think of extreme weather events and infrastructure resilience, but if that doesn't include public health, then you may have unintended consequences. That's kind of what we want to do, right? Or what we want to avoid. So we look at a few of these kinds of plots looking at categories of disaster-related mortality. So you can see that geological hazards, disasters tend to be dominant, because when you have things like volcanoes, tsunamis, and earthquakes, which are not in our control, they tend to produce lots of mortality. But hydrometeorological disasters produce the next highest at 41% over this period of 1964 to 2013. And as you extend this into the current year, let's say 2021, the numbers don't change that much, even though I don't have that to present here right now. Biological, so toxicity, exposure to those sorts of things, is 4%, and technological is 5%, which includes all kinds of accidents, industrial accidents, and so on. Looking at loss events worldwide for 1980 to 2014. I'm using different periods as the literature becomes available, and companies like Munich Re, which are reinsurance companies, also Swiss Re, for example, they insurance companies. So insurance companies sell insurance for homeowners, vehicles, industries, airlines, and so on, whereas when they need help to cover their clients, their insurers, they need to come to reinsurance companies. So reinsurance companies are very keen on knowing where the system is headed as a whole, and they track these things very well. So we are again looking here at geophysical events, earthquake, tsunami, volcanic activity, and meteorological events, which include tropical storm, extratropical storms, convective storms, and local storms, hydrological events like floods and mass movements, and climatological events like extreme temperature, drought, and forest fires. So you can see various numbers here. Loss events are those that have quantifiable loss of life, loss of property, and so on. So you have 21,700 loss events over this period, with a small percentage here, 12% belonging to geophysical events, whereas 41% are meteorological events, and 36% are hydrological events. Okay, we have climatological events of heat waves, etc. at 11%. Total number of fatalities is slightly different here, 1,740,000 over this period, with more than 50% accounted for by geophysical events, as we said before, and the rest here you see meteorological events account for 25%. And overall losses in US dollars at $4,200 billion. That's a massive number. And here 40% and 25% together are produced, 65% are produced by meteorological and hydrological events. So that should give us pause in terms of what climate change would mean in this case. Okay, insured losses. What's what Munich Re would worry about? 1,100 billion US dollars, and 71% of that is from meteorological events, which include tropical storm, extratropical storm, convective storm, and local storm. Okay, that gives us a sense of what we are dealing with, and for each of those we have to then look at what are the health impacts, right? Longer term, going from 1900, looking again at these various categories of biological, climatological, geophysical, hydrological, and meteorological. The biological have increased in the 1990s and have dropped off. Then you have geophysical, which are a small fraction now compared to meteorological and hydrological. So the overall drop here is not because of hydrological and meteorological, but it's because of biological and geophysical and climatological. So just keep in mind that climatological are extreme temperatures, droughts, and forest fires, which we will look at in a little bit more detail. It's a somewhat of an arbitrary demarcation, you can say. Okay, this is again looking at the 1980 to 2014 period. Weather-related loss events, now looking at year by year number of events. So here you see that there is a clear increase in meteorological, hydrological, and climatological events. Climatological events remain almost the same, but you can see that hydrological and meteorological events have increased over this time, clearly being manifestations of global warming. There are details in the sense population increase and people living in crowded places like urban centers with sea level rise and so on can actually contribute to this, and not just the physical events. Okay, it's the total loss events are how the impacts occurred, and that those impacts, for example, Roger Pilkey Jr. would argue that hurricane impacts increase because more people moved closer to the coast, right? So you have to be aware of those sorts of differences as well. The other way to look at that again here, 1980 to 2014, number of events with relative trend in percentages here. Geophysical events not showing a huge trend, but there is a 100% to about 150%. Climatological events and meteorological events show a trend, but the hydrological events show the largest trend. So extreme rainfall events and extreme droughts are not beginning to really add up. And there is now a concept called compound events. So you may have a flood, you may have storm surge, you may have urbanization and lack of infrastructure to get rid of the water above a certain rain rate, and so on and so forth, which also contribute to loss events. Okay, I will leave this here and come back to mortalities of various disasters. So we looked at broad categories of meteorological, hydrological, climatological events, leaving aside the geophysical ones, and we will look at specific types of disasters in each one of them, like heat waves, floods, droughts, wildfires, and then look at the biggest events that happened in each category and some of the health impacts we have to worry about. Okay, and then we'll try to put that in the context of disaster management to see how public health can play a role in designing holistic disaster risk reduction programs which worry about socioeconomic vulnerabilities, health vulnerabilities. Also, you can think of it as resiliences, and how now we cannot treat these components separately. Public health, extreme events, climate change, sustainable development, risks and risk reductions. They all have to be considered together. Okay, so we'll come back to that in the next podcast.